All right, this is the review sheet for Chapter 4 to prepare you for the semester exam. I'm just going to go ahead and work through all of these problems. And so here is your first problem. The first step is to do what we call scalar multiplication, 2 times this matrix here in the middle of the equation. So that needs to be taken care of first. So literally, it's like the distributive property with matrices. You just multiply 2 times every element. So that's -2, -6, +4, +10. Okay, we'll just do this a step at a time. All right, and just like in the past when we solved real number equations for a variable, we're going to follow the same process. So before I undo multiplication, I'm going to undo addition, and I undo addition with subtraction. So I'm going to subtract. I'm going to start with this matrix, and I'm going to subtract this matrix from it. So let me see if this makes sense to you. So I'm going to start with the element 13, subtracting -2. 13 minus -2 is 15. -9 minus -6 is -3. 4 minus 4, of course, is 0. And 16 minus 10 is 6. And it does matter that you subtract in that order. It's this matrix minus this matrix. And now it's pretty simple. We just solve for y by dividing all of the elements in the matrix by 3. 15 divided by 3 is 5. -3 divided by 3 is -1. 0 divided by 3 is still 0. And 6 divided by 3 is 2. And so that is our solution for the matrix, the unknown matrix in this problem. Okay. Number 2 and 3. We're supposed to multiply matrix A times matrix B. Well, let's see if it's possible. To know if it's possible, we write the dimensions. This matrix is a 2 by 2. This matrix is a 2 by 3. It's possible if the numbers on the inside match each other, and they do. So it is possible. The outside numbers, in this case the 2 and the 3, will tell us what our product matrix should look like. So we should have a 2-row, 3-column matrix as a product. And the way you multiply matrices together is by its row times column. So for this element, which is in row 1, column 1 of my answer, I'm going to multiply row 1 of this A matrix times column 1 of the B matrix. And you just match up the elements. 1 times 3, let's write that over here to the side. 1 times 3, and you always add, and then do -1 times 2. Just add those products together. 3 plus -2 is 1. Okay, so for row 1, column 2, use row 1 times column 2. 1 times -3 plus -1 times -2. Okay, -3 plus 2. -3 plus 2 is -1. Okay, now let's see if we can just do these mentally. So for row 1, column 3, use row 1 times column 3. 1 times -1, that's -1, plus -4. -1 times 4. So -1 plus -4 is -5. And now work on the bottom. Use the second row, and then we're going to go through using columns 1, 2, and 3 again. 3 times 3 is 9, plus -4. 9 plus -4 is +5. 3 times -3 is -9, plus 4. -2 times -2. So -9 plus 4 is -5. And then finally 3 times -1, that's -3, plus -8. -2 times 4. So -3 plus -8 is -11. So that's the product AB. Now the question is BA possible? Well, here's the dimensions for B. Here are the dimensions for A. If you compare the inside numbers, they do not agree. You can say something like, these don't match, therefore not possible. The inside numbers do not match up. All right, so that takes care of numbers 2 and 3. So let's take a look at number 4. One thing you should do that didn't show up on my printout, you may have already figured this out, but we probably should label these rows of this number of items sold. These 3 numbers are the number of hammers sold in each store. This matches up with this prices matrix. This represents the number of flashlights sold in each store, and this represents the number of lanterns sold. So once again, we're going to find the product of the 2 matrices. So in order to multiply them together, we need to make sure that we situate them properly. This is a 1 by 3, and of course this is a 3 by 3. Make sure I got those written correctly. All right, and so they do work if we multiply them in this way, and our result should be a 1 by 3 product matrix, 1 row, 3 columns. Okay, so let's get this first element, which should be the, since we're multiplying prices, these are prices, as you can see, times all the items sold. This will be revenue for store A, store B, and store C. You can call this revenue for each store. How much, another word for revenue, or a phrase for revenue, is how much money did they take in? They only sold 3 items. How much did they make from the sale of those 3 items? So for the store A revenue, we take $4 for each hammer times hammers sold, plus $6 for each flashlight times flashlights sold, plus $9 for each lantern times 3 lanterns sold. And we basically just add these numbers up. 32 plus 30, 62 plus 27 is 89. That's right. Just looking for my calculator just to verify that. I want to make sure, do the right thing here. So 32 plus 30 plus 27, 89. Okay. Now we'll do the same thing to get store B revenue. It's same prices, but the items that were sold in store B. So $4 per hammer times 10 hammers sold. $6 per flashlight times 12 flashlights sold. And $9 per lantern times 7 lanterns sold. 40 plus 72, 40 plus 72 plus 63 is 175. And then finally we can do store C. We can squeeze it up here. $4 per hammer times 6 hammers sold. $6 times 9, $9 times 4, 24 plus 54 plus 36. 24 plus 54 plus 36, 114. So find the product of these two matrices. There it is. And what does this product represent? It's the revenue or money that was collected from selling these three items at these three stores. I'll just say revenue. All three stores selling those three items. All right, how would you find the total gross revenue from all three stores? In other words, just how much did all three make combined? Well, you would just add those three elements together from our product matrix. Really didn't ask us to come up with that number. So just add them up. 89 plus 175 plus 114. In part A. Okay, just add those three numbers together. And then finally, find the total gross revenue from just the lanterns sold at all three stores. Okay, well, lanterns cost $9, so it would be $9 times store A's sales, 9 times 3, plus $9 times store B sales, 9 times 7, and then 9 times 4, 27 plus 63, plus 36, $126 would be your answer for part C. Okay, hopefully that helps you on number 4. Number 5, we have these number of people participating in fall sports. There's 4 different sports, and that's a matrix that's provided for us. The AD estimates that a certain percentage of these athletes will get awards, and that's represented in this 4x1 matrix. So what is the athletic director's estimate for the number of sports awards that will be earned? Basically, we're just going to multiply these two matrices together. This 1x4 which represents the number of participants, times this 4x1, which represents the estimates of people getting awards. And it's just another exercise in multiplying matrices together. So 25 times 0.2 is 5. So we're going to do 5 plus 30 times 0.5, which is 15, plus 50 times 0.3, also 15, 80 times 0.4, which should be 32, and we just add them up. 20 plus 15 is 35, plus 32 is 67. So our answer here, the estimate for the number of sports awards that will be earned will be approximately 67 athletes. Okay. This is another question based on a matrix that's provided for you. B1 and B2 are the cost per pound of Chinese greens or bok choy. So that's this column at market 1, and R1, R2 represents the cost per pound of rice flour at market 1, market 2. And the matrix to the left is just the amount of pounds that are being purchased at each. It's a half a pound of each type. So the question really is, what does Q in this product represent? Okay, well, if we were multiplying this out, this would be the row 1, column 2, so it would be 0.5 times R1, which is the rice flour at market 1, and then the bottom number, R2, would be 0.5 times R2, which is the rice flour cost at market 2. We would add these together to get a sum. So what does Q represent? The total cost for 1/2 pound of rice flour at market 1 and 1/2 pound of rice flour at market 2. Okay, so here's our rice flour market 1, rice flour market 2. That basically it's trying to see if you understand what it means to multiply these together, interpreting the results. And that should be your final answer for number 6. Okay, number 7, solve this matrix using an inverse matrix. Well, to find the inverse of a 2 by 2 matrix, you first must find the determinant. And to find the determinant, you do a little multiplication this way. 7 times 2 is 14. Subtract, multiply this way. 3 times 5 is 15. The determinant is -1. So we know there is an inverse. If the determinant was 0, then this 2 by 2 matrix would not have an inverse. So here's how you find the inverse, and then we'll actually do it. 1 over the determinant times the matrix dA, -b, -c. Okay, so what that means for me is 1 over the determinant times the 7 and the 2 represent the D and the A. We're going to switch places with the 7 and the 2. The other two elements, B and C, are going to change signs. And now that I've done this change, now I multiply by 1 over the determinant, which is just -1. And so -1 times 2 is -2, -1 times -5, -1 times -3, -1 times 7. Okay, so this is the inverse. And now that I've found the inverse, just bring this matrix on the other side of the equation and set it up to multiply times the inverse. And just keep in mind, this is very important. When you multiply the inverse times the matrix on the right side of the equation, the inverse must go first. It must go on the left. That's very important. Okay, so matrix multiplication. We have a 2 by 2 times a 2 by 1, so our answer should be a 2 by 1. All right, so this top number is going to be -2 times -9, -2 times -9, plus 5 times -4, so that's -2. And then the bottom number will be the bottom row times that same column, 3 times -9, plus -7 times -4, so that is 1. So this is the answer. That would be the matrix multiplied times this matrix to equal this right matrix. All right, same thing here. We need to find the inverse, so first find the determinant. Multiply this way, 3 times 5 is 15, minus -2, and so the determinant is positive 17. To find the inverse, it's 1 divided by that number times, this is where you change the elements around, switch places with the 3 and the 5, change the signs of the other two, and now multiply by 1/17. 5/17, -2/17, 1/17, and 3/17. 17th. So you have just found the inverse. Now, just bring this matrix down, put it on the right side, and get ready to multiply. And after we multiply these together, we'll have our answer. Okay, so we'll put our answer here. It should be a 2 by 2. And let's see, 5/17 times -10 plus -2/17 times 26, that's -52/17. All right, so we add those together and we get -102/17, and pretty sure that 17 goes into 102. Yes, so that should be -6. All right, now let's work on row 1, column 2, 5/17 times -11. And then -2/17 times -36, that's 72/17. And when you add those together, you get 17/17, which is 1. All right, now work on the bottom row. 1/17 times -10, -10/17. 3 times 26, 3 times 26, that's, I just blanked out, 78. 78/17. So we end up with -10 plus 78 is 68/17, which is 4. And lastly, we do 1/17 times -11, just row times column, plus 3 times 36. That's -108. It's -119 over 17. And that should be -7. Okay. And we have our answer. This is the matrix. If we plugged it in right here and multiplied these two matrices together, the result should be the matrix on the right. Okay, these last two are Cramer's rule. So for Cramer's rule, we need to make a determinant that uses just the coefficients of this system. -3, +5, +1, -3. And you remember how to find the determinant. That's multiplying this way is 9 minus 5 is 4. Okay, let's find another determinant called d sub x, where instead of these x coefficients, we're going to replace them with the constants. And the y coefficients will stay like they were. Find the determinant. -4 times -3 is 12, minus 20 is -8, and now always divide by this initial determinant of the coefficients. So -8 divided by 4 is -2. And then find d sub y. The x's, the x coordinates do not change. Replace the y's. And find the determinant. -12 minus -4, also -8, again dividing by this initial determinant that you got for the coefficient matrix. And so our final answer here should be -2, -2. Okay, and we'll just go ahead and run through this one as well. So find the determinant of the coefficients. 2, 4, -4, 2, 4, minus -16 is 20. Okay, find d sub x, replace the x's, don't replace the y's, just leave the y's alone. 40, just multiply this way, 20 times 2 is 40, minus, and multiplying this way you get 80, that's negative 40. And now don't forget to divide. Negative 40 divided by 20 is negative 2, so x is negative 2. And now find d sub y. The x's don't change, but the y's are going to be replaced. Find the determinant. Negative 40, going this way, minus 80, it's negative 120, and again divide by 20, the initial determinant. Negative 120 divided by 20 is negative 6. Y is negative 6. So as an ordered pair, we would say our answer here is negative 2, negative 6. Okay, and that is your review sheet for the Chapter 4 part of your semester exam. I hope that helps. And let me know if I can help you anymore. Let me know if you have any questions.